This video is meant to talk through Lesson 10, Modeling a Chemical Reaction. So on this first page, we have just goes through the law of conservation of energy, stating that energy cannot be created or destroyed. And then we have a breakdown of endothermic and exothermic with reaction or with in corresponding to energy. And I've summarized this over here, so I just want to kind of go through this really fast. So if you have an endothermic reaction, you're going to have the energy of bonds broken is greater than the energy of bonds made, meaning you're going to have more energy going into the system. For an exothermic reaction, you're going to have energy of bonds made greater than the energy of bonds broken. So this means more energy is going into the surroundings. So I wanted to look at these two kind of examples that we have. So on page 1, you have an example of an endothermic reaction, page 2, an exothermic, and then page 3, you're going to be drawing one of each. So it's important that we jot down some thoughts on what the summaries of each of these are. Okay, so we're going to chat about endothermic first, and I'm going to just kind of write down some notes that we see with the model. So the first thing that I want us to look at is the actual bonds broken and bonds made. And as I talk through this, me verbally talking through this will actually go through these answers at the bottom. Okay, so I'm going to kind of leave it up to you to discern that, but I just want to make sure that I'm being very thorough in going over these models. So here we looking at comparing the before to the during. I notice that I have this bond breaking. So 1, I have this bond breaking, 2, and then this bond breaking. Okay, so I have 3 bonds broken. Comparing the during to the after, I have this molecule or this atom is coming here. So 1 bond formed, and then this comes here. So 2 bonds formed. And then with my energy, looking at from the before to the during, you can see that I have kinetic energy going from the surroundings. So energy is going from kinetic energy in the surroundings to potential energy in the system. And then we have potential energy in the system going to kinetic energy in the surroundings. Okay, so overall, I have the system increases in potential energy, and the surroundings decrease in kinetic energy. Okay, so this all follows these two concepts. So I have more bonds broken than made, and I have my surroundings decreasing in energy and my system increasing in energy. So if I go here to the second one, this is an exothermic reaction. So if I'm, again, just kind of breaking down this model, I have, in the first one, I have this bond breaking, and that's it. So just 1 bond broken. And then over here, I have this bond being made and this bond being made. So 2 bonds made. And if I'm looking at my energy transfer, so this energy from this kinetic energy surroundings transfers into potential energy of the system. And then we have energy go from potential energy of the system to kinetic energy in the surroundings. So overall, we have system decreases in potential energy, and surrounding increases in kinetic energy. Now, there are some things that we actually see in both. Okay, so in both models, we have the surroundings kinetic energy changes in the end. Okay, so the surroundings has a change in kinetic energy, which makes sense because kinetic energy is synonymous with temperature. So if we have temperature increasing, that's when we see exothermic, temperature decreasing, endothermic, right? So we see the surroundings kinetic energy changing. We also see the system's potential energy changing overall. We also, even though we have different amounts kind of transferring in that first step, we have energy going from the kinetic energy of surroundings to potential energy of system in each one. And also in each one, for the second step, we have potential energy of the system going to kinetic energy of the surroundings. Okay, so we have that same kind of pattern happening in each of these, okay, with the energy, which I think this is the harder part to kind of sketch out as you're actually moving on to page 3. So for page 3, you're asked, now you will practice several chemical reactions on your own. Use the complete endothermic and exothermic chemical reaction models from the previous pages to help you. Okay, so they're saying use the information we got from the models before to help us sketch these models. In order to complete each model, start by drawing the atoms for the reactants in the chemical reaction and count the bonds present in the reactants that must be broken to form the products. Then draw the models for the products, count the bonds that need to be formed, use that difference to determine if it is exothermic or endothermic. Then create energy boxes to show the transfer of energy. Okay, so all you're going to be doing is you're going to be taking these models, sketching them out. You'll notice that these are a lot simpler than the models you were drawing before. Okay, so even CO2 is like this. If you are not sure what the actual, mine are looking kind of awesome, obviously. If you're not sure what the structures of these are, like O2 is a double bonded oxygen, for example. If you're not sure what these structures are, you can always go to Google and Google O2 structure and it'll come up, okay? Or CO2 structure, for example. Yeah, see? So you can always go back and kind of like just make sure that you are drawing these appropriately. You can also draw these on paper and then just put a note in here. Drawn on paper. You just need to make sure you email us that paper with the model on it. Okay. So again, we're just going by these actual parameters as we are drawing our models.